Hello everyone. So today I'm going to do a small seminar on the topic the auxiliary field H and some other small topics. So in order to understand the auxiliary field, we have to consider the Ampere's law in a magnetized material. We know that the bound current JB is given as curl over M and the surface current KB is given as the magnetization cross the normal. And total current can be written as J is equal to the bound current plus free current. Here the free current is due to the actual charges arising from the potential difference we apply. Now Ampere's law states that 1 by nu 0 over curl of B is equal to total current. That is, total current is equal to free current plus bound current. So substituting for bound current, we get 1 by nu 0 curl over B is equal to free current plus curl over magnetization. Now taking common terms together, we get free current is equal to delta cross 1 by nu 0 B minus M is equal to free current. And the quantity in this bracket, that is 1 by nu naught B minus M is known as the auxiliary field, or H. And the Ampere's law for H states that the curl of auxiliary field H is equal to the free current. And we can write this in integral form. The closed loop integral of H dot dl gives the total free enclosed current. Now let us do a question on the auxiliary field. A long metallic rod of radius r carries a uniformly distributed current I. Find H inside and outside the rod. Now in order to find the auxiliary field inside the rod, we construct an Amberian loop inside the rod with radius small r. And now according to Ampere's law, we get integral over closed loop H dot dl is equal to the free current enclosed. Here dl is equal to 2 pi r. Therefore H in 2 pi r is equal to I into radius of the Amberian loop divided by the total radius of the rod, the total area of the rod. That is I pi r square divided by pi r square. Therefore H in is equal to I r divided by 2 pi capital R square in the phi direction. This is the for the auxiliary field inside. Now in order to find the auxiliary field outside, let's construct a auxiliary Amberian loop outside the rod with a radius small r. Here the radius of Amberian loop is greater than the radius of the rod. Therefore H out 2 pi r is equal to just I, and H out is equal to I by 2 pi r in the phi direction. Now boundary conditions. The magnetostatic boundary condition gives that the B perpendicular above minus B perpendicular below is equal to 0, and B parallel above minus B parallel below is equal to nu 0 into K cross the normal. Now this can be written in terms of free current and the auxiliary field H. Here we take H as minus divergence of M. Therefore we get H perpendicular above minus H perpendicular below is equal to minus M perpendicular above minus M perpendicular below, and H parallel above minus H parallel below is equal to the KF cross the normal. This is the boundary conditions for the auxiliary field. Now linear and non-linear media. In most substances, the magnetization is proportional to a negative or positive factor of the auxiliary field. Proportion is magnetization proportional to H, and the constant of proportionality is called the magnetic susceptibility. And it is a dimensionless quantity that varies from one substance to another. And the materials that obey this equation are called linear media. Now non-linear media. Ferromagnetic materials are the main example for non-linear media. Ferromagnetic materials are nonlinear in response to the applied magnetic field, and consequently we know that M by H, that is the magnetization divided by the auxiliary field, is not a constant in case of nonlinear media. Therefore the external magnetic field is not a requirement to sustain magnetization. That is, they have net magnetic dipole moment even when there is no applied field. Thank you.